Hey guys, quick homework help here. I'm just going to do numbers 2 and 5 so that you can see how these are done. As you know from your notes, the conjugate is when you take a complex number and you keep your a the same. So we're going to multiply this thing by its conjugate. A is the same, but we have to negate the bi. That's all it is. So the conjugate is just the same thing as the complex number, but with a negative bi. And when we multiply it by this conjugate, something interesting happens. So you'll see we'll do 2 times 2. That's 4. 2 times negative 2i. 2i times 2. And 2i times negative 2i. And when that happens, you'll notice that the negative 4i and the positive 4i here will cancel. And that will always happen if you're multiplying a complex number by its conjugate. The reason that's so nice is because now we just have 4 minus 4i squared, but we know that we can simplify that I squared. That's just the same as having a negative 1. So what we really have here is 4 plus 4, or 8. So that's number 2. All right, now for number 5, you have to graph both the complex number and its conjugate on this same set of axes. So first, let's start off just by graphing number 5. We have to remember that this is our real number line, and this is our imaginary number line. And we don't have enough lines here to count by 1, so let's count by 3s. All right. And on the imaginary number line, we can just count by 1s, so we don't have to do anything there. So we would go over to 9 and up to 1i, and that point would be right here. 9 plus I. Make sure we draw our vector, and that is the complex number we're given. But remember, we also have to graph the complex conjugate. So the complex conjugate is going to be 9 minus I. Well, that's still over here at 9, but we have to go down to negative I and plot our point here, then draw our vector. And it's as easy as that. The point that I'm trying to get you guys to see here is that a complex number and its conjugate are exactly reflections of each other over the real number line. That's all this is. So it almost looks like you just took that original complex number and just reflected it over the real number line. And that's going to happen with every one of those. All right, I don't think the complex conjugate is too crazy of a concept, so good luck finishing this up, you guys. I'll see you tomorrow.